Hi, welcome to the first lesson of Unit 3. In Unit 3, we're going to take a look at rational functions. Rational functions are incredibly important in modeling real-world situations. So many of the things that are going on around us in the real world are modeled with a rational function. And we're going to start off by taking a look at what rational expressions are and identifying where these rational expressions fail to exist. It's important to keep in mind that these are incredibly important for your understanding of calculus. And when you move on to calculus, so much of what you will be studying are rational functions. You'll be building them and using them to model real-world situations. So this is incredibly important. Let's go ahead and get started. Alright, so let's begin. Why don't you go ahead and copy down this question in your notes and answer it to the best of your ability. Remember, you don't need any new information. You just want to apply understandings that you already have, test some x values out, get creative, and then try and explain why your answer makes sense. Alright, so you're trying to determine where this expression, 5 divided by x, does not exist. And that's a new term, perhaps for you, and so thinking about the words does not exist, what you're looking for is a place where this expression, an x value, where this expression just makes no sense, where you can't actually say what the value of 5 divided by that x value is. So let's try some x values out that, should make perfect sense, and that'll hopefully help us get to one that doesn't. So maybe you start with 1. Okay, well, when x is 1, 5 divided by x is going to be equal to 5 divided by 1, which of course is 5. Okay, so that makes perfect sense. It clearly exists when x is equal to 1. Maybe you try some other ones, like maybe you try, negative 1. Well, 5 divided by negative 1 is negative 5. I'm like, okay, well, that clearly works, so positive and negative values work. What would be something where I would not be able to divide 5 by that value, where I just couldn't say what that number is going to be? And hopefully you arrived at 0. If you try and take 5 and divide it by 0, well, think about it. How many times does 0 go into the number 5? It doesn't matter what number you come up with, you're wrong, because 0 times that number that you come up with won't equal 5. And so there's no way to say what this is. In other words, 5 divided by 0 does not exist. So when x is equal to 0, our expression is what we call undefined, or in other words, it does not exist. Now, this isn't just the case for 5 divided by x. This is the case for any number divided by 0. And so what we'd like to do is explain how we know that taking a number and dividing it by 0 results in something that does not exist or that we cannot define. And I'm going to take you through a couple of different ways to explain why a number divided by 0 does not exist. So to do this, let's think of something maybe a little easier than 5 over x. Let's think about something like 1 over x. And so we can think about what would happen as you're getting closer to 1 over 0. So what we're going to be considering is, what is 1 divided by 0? What is that equal to? If you type this in your calculator, you'll see that 1 divided by 0 is undefined. Why is that? Well, let's think about this. Let's say you had 1, and instead of dividing by 0, you divided by things that were getting closer and closer to 0. So start and you take 1 and divide it by 0.1. Alright? Well, there you're going to get 10. Now let's get even closer. Let's do 1 and let's divide by 0.01. There you'll get 100. Alright, and let's keep getting even closer. 1 divided by 0.001. There you'll get 1,000. Now let's take it even further, and let's get sort of extreme here. Let's go with 1, and let's divide by a really, really, really small number. So let's do 0.0, let's do 5 zeros. 1. All right, so if you type that in your calculator, you'll find that this is 1 million. Okay, so by this logic, as we get closer and closer to dividing by 0, the value of our expression is getting bigger. And we can assume, look, if you just kept adding zeros in here, your expression would just keep getting bigger. To the point where you might say, well, 1 divided by 0, that should be positive infinity. It's an infinitely big number. So based on this line of reasoning, you might say 1 divided by 0 is equal to positive infinity. Okay, so it seems like maybe we figured out what 1 divided, or any number divided by 0 is going to be. It's going to be infinity. But let's come at it from a different angle. So instead of dividing by numbers that are positive and are getting closer and closer to 0, remember there are still x values that are negative that get closer and closer to 0. All we do is take the negative version of these numbers, and we're still getting closer to 0 kind of from the other end, right? So here we're approaching 0 from the positive end, from the right side, and now we'll approach 0 from the left side. So let's try 1 divided by negative 0.1. Well, here you'll get negative 10. Now let's do 1 divided by negative 0.01, and you'll get negative 100. All right, let's just fast forward. We know that 1 divided by negative 0.001 will be negative 1,000. So let's go all the way to our extreme, and let's do negative 0.000001, and here we'll get negative 1 million. So what seems to be happening here? Well, as you're getting closer and closer to x values, divisors of 0, but from the negative end, you're getting more and more negative values. So that would seem to lead you to believe that, well, as you're getting closer to 0, 1 divided by that number is going to be getting more and more negative. So you're getting closer and closer to negative infinity. In other words, this would lead you to believe that 1 divided by 0 should be equal to negative infinity. Well, negative infinity and positive infinity are very different values. They're as opposite as you can get. So there's no one correct answer for 1 divided by 0. And so mathematicians say that 1 divided by 0 simply does not exist. In other words, any number divided by 0 does not exist. In other words, it is undefined. So you can either use the term does not exist or undefined. There's no concrete definition here. And in class, we'll take a look at why 0 divided by 0 is still undefined. So I'm going to pose this question to you now. Consider, I'll write it down here, consider 0 divided by 0. What does that equal? And we will discuss it a little bit in class, but you should spend a couple minutes now thinking about whether 0 divided by 0 is undefined and why or why not. But now let's go ahead and move on, and let's take a look at rational expressions in general. So this was an example of a rational expression, and now let's define it and take a look a little more closely at some rational expressions in real life. All right, a rational expression, and within the word rational is the word ratio, and this helps us remember what a rational expression is. A rational expression is a ratio of two polynomials. A rational function can be written as f of x is equal to p of x divided by q of x, where p and q are polynomials and q is not 0. So this expression can't be 0, right? We saw before, you divide a number by 0 and it does not exist. So a rational expression, this is a rational expression, right? A rational expression is a ratio between two polynomials. So you can think of it as taking polynomials and dividing them by one another. And so we've studied polynomials in the first couple of units, and now we're going to take polynomials and divide them by one another. And rational expressions for this reason are very useful because a lot of real life situations involve division. And so by being able to look at functions where you're dividing one thing by another thing, it'll allow us to model real-world situations very nicely. Now there are a couple things that we want to take note of. When we have a rational expression or rational function, we're dividing two things. And we just saw that when the denominator is equal to 0, there is no value that exists. It's undefined. So the dividing polynomial, the denominator, can never be equal to 0. So the polynomial in your denominator, in this case we've referred to it as q, cannot be 0. So when q is equal to 0, anytime that your denominator is equal to 0, we say that the rational expression is undefined or does not exist. Okay, and this is a term, undefined or does not exist, are terms that show up a lot, particularly in calculus, and so it's very important that we're able to figure out where these places that the function or the expression is undefined or does not exist. And so these are going to be anywhere where our denominator is equal to 0, we say that the expression is undefined or does not exist. Sometimes you'll see undefined abbreviated U and D, and sometimes you'll see does not exist abbreviated D N-E. So be on the lookout for that. But we'll want to write it out just to be clear. Let's take a look at a couple of examples of some rational expressions. Okay, take a look at this expression here. This is a rational expression. Why? Think about that. Why is this a rational expression? Well, looking at the definition, a rational expression is a ratio of two polynomials. This is a polynomial of degree 1. This is a polynomial of degree 1, and it's a ratio between the two of them, so this is a rational expression. Now, we want to think about where is this expression undefined, or where does it not exist? It will not exist whenever our dividing polynomial, the denominator, is equal to 0. So you can think about this. This expression does not exist when x minus 1 equals 0. Now think about that for just a second. What x value would make x minus 1 equal 0? This is very easy to solve. In fact, we don't even need to do the algebra. Just looking at this, we can see that that will be when x is equal to 1. And I can do that by adding 1 to both sides and solving. So when x equals 1, this expression does not exist. So think about that from a graphical standpoint. Let's just say we were graphing this function and you were coming along and you were plotting a bunch of points. Would you be able to plot a point when x is equal to 1? And the answer is no. You'd have no way of defining what this expression is equal to when x is 1. And so we say that this expression does not exist or is undefined when x equals 1. Alright, what about this function here? This expression. Is this a rational expression? And the answer is no. A rational expression is a ratio of two polynomials. Unfortunately, 2 to the x is not a polynomial. This is an exponential function. We'll talk about those later on in the course, but this is not a rational expression. While the numerator is a polynomial, the denominator isn't. Let's take a look at one more quickly. Alright, take a look at this expression here. Very quickly, decide whether or not this is a rational expression. Why? Hopefully you said that this is a rational expression because this expression is a ratio of two polynomials. We have a polynomial, 5x plus 3, divided by another polynomial, 2. Notice that these are very simple polynomials, but that doesn't make them not polynomials. This is a first degree polynomial, and this is a polynomial of degree 0. So this is a rational expression, and let's ask ourselves, is there anywhere that this expression does not exist? Well, in order for a rational expression to be undefined, we would need the denominator to be equal to 0. But the denominator is a constant. It's always 2. In other words, there's no x value that will make this equal to 0. And so this function here is always defined. There will never be a place that it does not exist. Now that we have a firm understanding of what rational expressions are, what we're going to do is take a look at some situations where we have rational expressions. We'll find where the expressions don't exist, and then we'll also take a look at some real-life situations where a rational expression can give us some meaning about a situation. Alright, let's start with this here. Go ahead and pause the video now and try this one on your own. You're fully capable. And then go ahead and press play to confirm that your solution is correct. Alright, so we can say that our function f, or f of x, will be undefined when, and of course a rational expression is undefined, and this is a rational expression, when the denominator, the function in the denominator, is equal to 0. So this will be undefined when our denominator equals 0. Okay, so going back to our ability to solve equations like this, we know that we have a factored form quadratic here, and this makes it very easy to see what x values will make the equation true. If we have two things multiplied together to equal 0, our only options are for one of them to be equal to 0. So to make x plus 2 equal to 0, x will have to be equal to negative 2. And for x minus 3 to be equal to 0, x must be equal to positive 3. So these are the two x values where our function f of x will be undefined. So another way that we could write this is we could say f of negative 2, the function evaluated at x equals negative 2, is undefined or does not exist because this results. And why is this undefined? Well, remember, that's because if we had an x value of negative 2, our denominator would be 0. So this will result in division by 0. And of course, that makes it undefined. And so I could say the exact same thing for f of 3. Just put quotes there to show you that the reasoning is the same. Alright, let's go ahead and take a look at a real-world example. Alright, you're going to go ahead and complete both of these problems on your own, and I'm going to talk us through number 2 just a little bit. A car makes a trip of distance d miles and then returns. The time it takes to make the outgoing trip is t sub 1, and the time for the return trip is t sub 2. Describe the meaning of each expression in the context of the problem. So for part A, we have d divided by t sub 1. Remember, d is the distance that it takes to go to that place. T sub 1 is the time it took to get there. And so you want to think about what information would that tell you if you took d and divided by t sub 1. If you're struggling with this, I would recommend giving these variables some actual values and then writing them out. So for example, you might give d miles, say, okay, let's make d 10. So it took 10 miles to get there. And t sub 1, say it took 5 minutes. And then you can actually rewrite this expression with your values. So 10, or what do we say, 2 miles. 2 miles divided by 10 minutes, and think about what that means in the context of the situation. For number 3, this is very similar to what we've been asking all along. For what values does this function not exist? Explain how you know. And then what are the roots of the function f of x? So you might want to quickly remind yourself what roots are again. For number 3, I'm going to post the correct solution. I'm not going to show you the work, so you need to check your work with the solution to each part of number 3. And number 2, you should make sure you have done on your own. Alright, I'm about to post the solution for number 3, so if you haven't finished yet, make sure you pause the video so that you don't see the solution before giving it a try. And as always, remember, your work is what's important. You should only be using these solutions to check your work. So when I'm looking back at your work, I want to make sure that that is there. Alright, so there are the answers. Make sure that you have reasoning for both of them, particularly for number 2. And I will see you guys soon.